कुछ लोगों से बात की and kind of figured out कि most of the people here are from colleges. तो college में कितने से हैं? Wow, that's majority. और आप लोग क्या कॉलेज में C++, Java, what kind of programming languages are you using?
Python.
Python, interesting.
Right now we are in Python, earlier we had C++, then Java, and right now we are.
हाँ वही switch होता रहता है.
Switches.
अच्छा उनके मतलब वो होता रहता है.
हाँ.
And what about मतलब C++ अभी कौन मतलब जानता है like who uses C++ regularly?
कुछ तो नहीं मतलब
But okay, use कौन करते हैं anyone? Yeah, this would have been a good thing to flex as a computer lab में जा रहा हूँ, है ना? और flex करना है दोस्तों के साथ. अच्छा, compile करना है. Wow, I wrote it with one command. और सारे bindings के साथ बनाएंगे. This would have been a nice tool to flex. So the way this talk is structured is I'm going to ease into it. We're going to start with a story about myself, and then we're going to ease into how I got into learning Make, and then I'm going to teach you guys how Make actually works. And we're going to have live demos. So किसी के पास अगर laptop है, you guys can put it out and try it out while you're doing it. So yeah, and this is a short note. This is a link to the GitHub repository that contains the resources used during this talk. तो आगे जाके अगर आपको यूज करना है if you want slides, it's all available there. Are we done? So अगर LinkedIn में जाना है, my name is Alok Joshi, connect us, okay? And yeah, moving on. About me. So the way I got into tech was curiosity. है ना? 6th or 8th से start playing around. और मेरा ये था कि आप डेवलपमेंट वगैरह करना था. And then आप डेवलपमेंट हुआ नहीं, I wanted to do iOS development, didn't have Mac. तब से Windows PC यूज कर रहा था. And I got into this thing called Hackintosh. Does anyone know what Hackintosh is? Yes, you're an amazing guy. So it's a very niche community जहाँ पे people run macOS on Windows. और वहाँ से start learning concepts of operating systems or कैसे how CPUs read जो operating system files के कौन से कैसे काम करते हैं वहाँ से मैंने सीखा था. And that's when I decided I wanted to pursue a career in computer science, and I joined NIT Bhopal. That's me. College में पढ़ने और सुनने के अलावा मुझे सब कुछ करने की serious is me during graduation day, sleep deprived. And one of the requirements was to do an internship with 6 months internship was the end of your degree. So मैंने किया सोचा कि let's do it in finance क्योंकि reading लगा था और तभी stock market का craze was like all-time high. So I joined NSCI. For those of you who don't know, it used to be a branch of Morgan Stanley, and then they spun it off as a company of its own. And वहाँ पे I met a lot of interesting people. So the thing is, बहुत से लोग enterprise tech like Microsoft वो सब छोड़ के यहाँ पे आ जाते हैं because these guys sell enterprise services to जो भी traders वगैरह उनको बेचते हैं like Bloomberg. And वहाँ पे like you have people with diverse skill sets, and that's where I learned about UI, UX, developing proof of concepts. Using HTML, CSS, और उसका use करके you'll be developing applications and then you'll be showing people, okay, this is how it's going to work. And then we started to थोड़ा सा experiment किया. Once done, I was like, hey, let's try something else. Let's go with something core tech, and that's when I joined CNOP. CNOP में I work with a primarily Linux-based environment. We work on embedded systems, and काम is mostly C++ में रहता है. तो C++ में जो किया था, I was like, what's there to learn C++? College में जो करना था कर लिया था, ये से कर लिया था. And that's when they introduced me to this system called EWEM. The EWEM, if you study computer networks, it's TDM सुना होगा, FDM सुना होगा, division multiplexing, time division multiplexing, frequency division multiplexing. This one is wavelength division multiplexing. So you'll be multiplexing multiple wavelengths in an optical fiber, and you'll be sending it across long distances. The issue is if you have wavelengths similar frequency, it's going to collide, and because of physics, right? And it's not going to work out. So they have to figure out a way to have multiple wavelengths of, say you have 400 nanometers, and you only use 405 nanometer wavelength. that comes under EWP. This is what it looks like. It's tall. The picture doesn't do justice. Or इसमें जो software use होता है, it's absolutely massive. So if you can see this here, these are three subsystems within the system itself, and they have individual tasks. और सब में अपने अपने C++ programs चलते हैं, right? And like any tech company, they would all store their code on Git. कोई VCS होगा, they'll be storing there. And then comes the question: you have almost 6 GB of your C++ code, और अगर कोई issue आता है, you want on the field, you want to deploy it as quickly as possible. How are you going to do it? So, yeah, before I go ahead, does anyone have any idea कि हम लोग कितने time में करते हैं? Like from production code to the deployed system, like how much time does it take approximately? Any guesses? Roughly चलेगा?
10 minutes.
Okay, that's ambitious. Anyone? You're pretty close actually.
20 minutes.
15 to 20 minutes is roughly the range you have right now. So, and it's crazy. You have like a lot of C++ code, external dependencies you work in. How do you compile it as fast as possible, deploy it on the system itself, and make sure that the system is stable and stored with that? And it needed two things. Yeah, you have a question, how do you do this? And one is creativity, and the other two you're using is GNU Make, of course, that's what Thomas is about. और जब मैं creativity की बात करता हूँ, you need a lot of creativity. And personally, जब मैंने आपकी code base देखा at the company, like, I saw the kind of code they've written, absolutely crazy. The amount of creativity used here is, beyond anything, at least I've imagined. So अगर आपको देख के you'll be like, wow. So that's where it comes to this topic, introducing GNU Make. Basically. So what is Make? So it's a build tool used to compile C++ applications. Or just as we have a lot of other languages and frameworks that help you build applications as fast as possible. Say around Python use career. Like Python doesn't have it. Python and a couple of other languages, but usually different ones don't have it. JavaScript use career. Yeah, you run npm build something that is there, right? Or basically you have Make over here. And the best part of Make really compiles what you need. जो unnecessary changes of Make and some bindings that have been changed, it's not going to compile that. It will only compile what you need, link it, and hand it over to you. So you want to send somewhere, it's send it to you. So yeah, now we're getting into the demo part. So if you're interested in running it right now, that's how you install. Windows people, you need to follow certain steps. The next couple is people, so we're going to start off with first off, this is it. So I'm running WSL tools, maybe Ubuntu version 20 each other. And yeah, we're going to start off.
Can folks at the back see this? You should.
Oh.
You can ask maybe. If not, you can zoom in.
A piece is visible, right? You guys can see? Okay, that's it. So, a point to note is that most of these, like all of this code has been tested on WSL on Ubuntu. So you'll have to make certain changes before running it on Windows. So, okay. I'm going to start off by creating. Okay, yeah, here. We're going to start by. So, the thing about Make files is that you have to name it a main file, you can't really have say the way it works with log files. You call it log files, and the log automatically picks it up and then runs for you. So we're going to create a main file. Yeah. And for starters, we're going to run this line of code called hello world. Standard practice. We will never see what hello world is always there. And save this. And I'm going to run make. And it echoes hello world back to me. Can you guys see this? दिख रहा है? So that's how make works. And the thing that defines what we did there was we created a rule telling the program how to what to do and how to do it. So we specified an action, and that action specific action was carried out. And if you notice that we added, there were 3 different segments to the rule. One first was the target, then there's prerequisite files which wasn't there in this case, and then you have the recipe, which was the echo command in our case. So if I open the file again, so if you see this line, this is the recipe itself. And it's going to look more like this. You have target, and then you're going to mention the files you need. And then once you mention all the files, you run the recipe. And an important thing is that जब आप ये recipe डाल रहे हो, there should be task trace to know that it's a recipe. So yeah, wait, and if I say rename this from hello to let's say false or something. So in call false, the main file means to run call false and perform that specific action for you. So we move on to the next one, that's creating the second main file. This was pretty easy, we didn't do much. And थोड़ा सा और complex हो गया, you're going to see how to compile C programs. So we're going to head over to the next one, where we have a C program. It's a very simple C program. I stream and there, and we're going to print out I command my first program easily. And then if you look at the make file, we have 2 tasks over there, 2 targets, if I will use it right. First one is name, and the second one is clean. So if you look at the first 2 lines, you have the target, you have the prerequisite files, and then you have the recipe itself. And you're telling me that you're going to be using main.cpp as the file that you want to compile, and we are going to be telling how to compile the particular file. So this is a standard G++ command. You're going to take the main.cpp, and our output will be my first main output. So if I go and I run main, it's going to run G++, and it's going to give me an output. So yeah, so here's our output, exactly the way we specified. Well, that's your second mini file. That's how it works. Say for some reason I changed my program and I just want to get rid of it. I don't know what, like, say there are a lot of binaries out there and it's not feasible for me to erase it easily. I'm just going to call, I've defined, I've told me what files I want to remove once I'm done with it. And I'm going to run this command called make clean. And it's going to remove those files. So if you look at it, so if you look at it, the output file is no longer there, which was there before. So that's your second make file. And now that you've compiled the program, you might be intrigued to know, how do I add external dependencies to C++ program? Kabhi aisa hai that open source software use karte hain, and you want to link it to your program. that's okay.
Albert, can you zoom your base code a bit?
Is it still small over there?
Yeah, it's better.
Okay, and come to the dependencies part of it later. We start with the reduce. So we have this row here and say I want to call it name. We can rename it again and program something. And it's still going to compile it for you. And now there's an important thing to note that since we removed the old files, that's why it's been compiling. But otherwise, we didn't make any changes, so we didn't do anything. And yeah, so one of the interesting things about main files is that they have variables and functions. So some of these variables are automated; they can automatically detect what files you're using, and then fetch them for you rather than you having to specify each and every file individually. And wait, before I go to the next one, I'm going to introduce you to something else. I'm going to introduce what code we've been compiling. So, honestly speaking, I love iPhones, but if you've seen the latest iOS 18 release, it was awful. It was awful. Who wants to take that? It's been just using iPhones. Now that they switched to Android. So that's why I'm introducing my own phone. It's called Foss Phone. And I think it's the greatest phone that's ever been created. Yeah, it looks amazing. Look at this guy. अच्छा लग रहा है ना? And एक issue is that it doesn't have an operating system. So you have to build one, and you're going to get it right away. So I've created a sample code base for us. So it has an in folder, include, and a source folder. Source here you have main.c, and it's a simple C program, C++ program. It just says welcome to Foss, and it can tell whether it's been compiled for a phone or a laptop. And then and we've included a header file here, say you obviously have certain dependencies, you make your own classes and other functions. So you have your own include files, and we created Foss include.h. And it's just there's a function over here, and we will be calling that in our main program. Now the interesting part will be heading over to the main file. Okay, and this is our main file. We've defined an include path over here. So it's going to go to this part and take all our include files. We define our source path over here. It's going to go to this part, take all our source files. And there are flags. So you use flags with G++, and we specify it over here under the main CP flags. And target is the name of the binary object you want to call. And finally, we're going to tell Make you're going to run this action called OS, where you're using the files in this source path and include path. And these are the flags and target will pass. Now, one thing I want to highlight over here is this thing that I'm using. It's include path equals to percentage equals %percentage. So what this does is wildcard matching. It's going to go through the entire directory. It's going to fetch all the files and pass it with the -i character as a prefix. So you don't have to include each and every include a hash include every .h file. So let's go back to and we're going to run make OS over here. You can see it ran the program for me, and it took the main file, added the flags, which in this case was phone, and added my include files over here, and specified the name of my operating system. So if I run it, it says relative false, whereas this is a function from the header file, and you're running this on a phone. So if I were to show it to you guys, include.h, it says this is a header file, you find it over here under the main function. And if you go to our source, main.cpp, we've had a header bar called phone. So if you're compiling for different devices or different types of program, or you just want different header bars within your program, you can use these header bars and add it as flags to your main file. Now, so what if I have multiple header bars and I want to compile for different objects? And that's where we see functions. So first thing I'm going to do is we're going to run main key. We're going to get rid of all these objects, and we're going to head to the second file. And you can see a couple of changes here right from the get-go. Of course, you have a include path, source path, and all of them, and you have OS and clean as actions. But you can see a function over here called if equals. So once we run main, we're going to pass parameters in the command. Say I want to build for a phone. So if I'm building for a phone, it's going to run. It's going to add. In this case, I define add these flags, and this is going to be the name of the target. Otherwise, you're going to build it for a laptop. So the way it goes is, so I'm going to run make OS. Okay. You see, the name of binary is laptop OS.org, which is what we defined over here. And if I would run the program, you'll see that you're running this on a laptop, which in our code we define it under a header. So, yeah, so that's our operating system for the phone. And before I go ahead, there are other functions I want to show you. And these are the variety of range functions that we can use with Make, and according to your preferences and whatever is convenient for you. So the first one is the if statement itself. You use if equals. Say if you want to try run an if condition within the main file itself, you use an if statement. So the way you use it is say I've defined a variable called foo, and it's going to take in a variable called empty. Say if it's empty, it's not going to do anything. Otherwise, it's going to print in else. So yeah, it's going to be a statement, and that's what it's showing over here. And say if you want a condition, you want to do something over and over again, and so you use the for function. So what we've done over here is we define two variables called foo and bar, and foo has a string called who are you, and bar takes in that string, parses it, and prints the same with an exclamation mark. And yeah, so yeah, if I run make for, it says who are you, exactly the way we define. And say if I want to write my own function that does its own thing, I define a function over here called my awesome function. It takes in, so the way you pass parameters is you just pass it, you can't really name it. And we're calling in $0, $1, $2, like that, across the names of the way you take in the script shell parameters. So the 0 will always be the name of function, and the variables start, the parameters start from 1 to 3, so on. So run make, and call this. So it says run call function, it says variable name, first, second, third, false is awesome. And yeah, that's all of it. And that's how you use main files to build objects easily and quickly using C++. So there are some standard practices we need to follow while using Make files, and that is each build step has something unique to as an output. So we artifact as we binary file something and all. The artifact should be accessible to the Make file, and you name the artifact appropriately within the recipe itself. And every time the recipe is executed, your artifact itself should be updated. And say for some reason you didn't pass in the right parameter because you messed up something somewhere, and the recipe fails, it should return a non-zero value to Make. And yeah, all the dependencies of the artifact should be properly mentioned within the Make file so that the program can access. And then there are some standard targets. So these are standard used across the industry, whether when you do over open source repositories, you find it over there. So the first one is clean. Clean is supposed to delete all the files in the current directory that are created when you build the program, and no other files or directories should be affected by this. And no configuration file anything should be affected, obviously. And directories, like whether or not deleting directories is up to you, but I don't think there's any need to do it. And then you have this command target called all. It compiles the entire program. It shouldn't include the documentation, just the program itself, and it should send it to wherever you want to be sent. And then you have Make install. So you compile the entire program with all these executables and all the values are in, and you tell it where it should decide for actual use. And do not strip executables. So when you strip executables, you remove the essential information that's there in binary training space. That's not recommended. And so try not stripping the executables. And yeah, and obviously it shouldn't modify anything in the directory where the program is set. So yeah, so if you want more information on standard targets, then just check this URL. And yeah, for standard practices, there's a document by MIT where you can learn more. And that's it. Thank you. Are there any questions? Anyone with a question? Try to tell me if there's any question, you can reach out to me. You have this information. And that's it. Thank you.
Questions नहीं है किसी के भी?
Hi folks, thank you for joining us. So that is the end of the meetup, and